Okay, so last lecture we have seen what is the relation matrix and how to represent any relation with the help of graph. Okay. So today we are going to see some examples just from it. Then we will see next one. So here question number 151 has let x is equals to set 1, 2, 3, 4 and relation r is equals to order pair x comma y such that x is greater than y. Then draw the graph of R and also give X matrix. Okay. So here this relation R is defined on set X, which is consists of 4 elements 1, 2, 3, 4, and we have to define relation R such that it will be consist of order pairs X comma Y such that X is greater than Y. Okay. Now, from this X, we have to find such order pairs where first element is greater than second element of that order pair. So, we can define relation R is equals to, it will consist of set of order pairs like 4 comma y. Why we have taken 4 comma y? Because 4 is greater than 1. Okay. So here this condition is satisfied that x is greater than 1. Now second order pair 4 comma 2, 4 comma 3, then 3 comma 1, 3 comma 2 and 2 comma 1. So here we have find out all three possible order pairs where first element of that order pair is greater than second element. Okay. So till now just we have defined relation R. Now we have to find what is the graph of R and what is the matrix for given relation. Okay. So first of all, we will find what is the matrix. So this matrix will be consist of 4 by 4 as 1, 2, 3, 4. These are the rows. Again 1, 2, 3, 4. These are the columns. Okay. Now consider the first order pair. That order pair is 4 comma 1. So we have to check for fourth row and first column. So fourth row and first column. So we have to mark that one as 1. So what is meaning of 1 here? So it represents that order pair 4 comma 1 is present in relation R. So likewise we can take another order pairs like 4 comma 2. So again fourth row second column. So again that order pair is present here. That's why we have to mark it as 1. Then 4 comma 3. So fourth row third column. So mark this one as 1. Then 3 comma 1. 3 comma 1 that is 1. 3 comma 2 third row second column that is again 1 and 2 comma 1 that is second row first column. Again mark that one as 1. And for rest of places we have to mark as 0 because those order pairs are not present in relation R. So this is regarding matrix of relation R. Now we have to draw graph of relation R. So for this graph again we have to take 4 elements, that is 4 circles to represent 4 elements of this set as 1, 2, 3, 4. Okay. So we have taken here 4 circles to represent 4 elements of that set. Okay. So now we have to draw graph of this relation R. Okay. So first one is first order pair is 4 comma 1. Means what? That R is starting from 4 and it ends at 1. That's why 4 to 1. They have represented it by R. We have drawn that arrow there, starting from 4 and ending at 1. Then 4 comma 2. This one again that R will start from 4 ends at 2. Then 4 comma 3. 4 comma 3. Again that should be represented by this arrow. The meaning of this arrow is very important. 4 comma 3 is so that R starting at 4 and ends at 3. Now 3 comma 1. Starting at 3 ends at 1. 3 comma 2. Starts at 3 ends at 2. And 2 comma 1. Starts at 2 ends at 1. Okay. So in this way we can represent any relation with the help of matrix and graph. Have you understood this problem? Hello?
Yes, ma'am.
Okay. So these kind of problems are asked for 8 marks. So this chapter is very important, and based on this you will get at least one question in final exam. So these are very important examples. So focus on it. Now second question is given as, let A is equals to ABC and denote the subset of A by B0 to B7. According to conversion, then convention, thus B0 is equals to 5, B1 is equals to set C, B2 is equals to set B, B3 is equals to set B comma C, B4 is equals to set A, B5 is equals to set A comma C, B6 is equals to set A comma B, and B7 is equals to set ABC. Then give the matrix of relation if relation R is the relation of proper individual on subset B0 to B7. Okay. So here they have defined one relation of set A, which is consist of 3 elements as ABC, and again they have given the subsets of A, and those are represented from B0 to B7. Now they have asked us to find the matrix of given relation. Okay. So here first of all we have to identify how many elements would be there in this matrix. So matrix of 8 by 8, that is from B0 to B7. So there would be total 8 rows and 8 columns, like B0 to B7, again B0 to B7. Okay. Now here they have to find matrix, and for that purpose they have given one condition. Relation R is a relation of proper integers. Okay. So in this set theory we have seen what is the definition for proper subset. So can anybody tell what is the definition for proper subset? Yes, what is the definition for proper subset? Okay. So I will tell you what is
Subset of
meaning
B,
by proper.
A is not equal to B.
Yes, correct. If there are two different sets A and B, then A is called as proper subset of B. If A is subset of B, but A is not equals to B. So this is the definition for proper subset. So same definition we have to apply here. So now check which one is a first row. B0 is a first row and B0 is the first column. Now we have to check what we can mark here, either 0 or 1. Okay. So now check B0 is subset of B0. Okay. Because every set is subset of itself. That's why B0 is subset of B0. But whether B0 is proper subset of B0, no, because what is the definition for proper subset? Those two sets should not be equal. But here B0 is equals to B0 That's why we have to mark here 0. B0 is not a proper subset of B0. Okay. Now, B0 and B1. If you consider this, so now check for B0. B0 it is phi and phi is subset of every set. So we have to mark here for B0, B1 it is 1. Again for B2, B3, B4, B5, B6, B6. For rest of all subsets we have to mark here 1 because phi is subset of every set. So just remember here why we have marked here 0 for B0. Okay, because we have to apply here definition for proper subset. And according to this definition, these two sets should not be same. But B0 is equals to B0 here. That's why we have marked here 0. Okay. Now check for this second row. That row is B1. Okay. Now check whether B1 is proper subset of B0. B1 is consist of set C and B0 is consist of phi. No, this is not a proper subset. Now B2, B2, B1, B1. Again, this cannot be proper subset because again these two sets are same or equal. B1, B2, B1 is consist of set C, B2 is consist of B. So again, there is no any subset here. That's why we have to mark here 0. Now B1, B3. Now check for B1. B1 is consist of set C and B3 is consist of set B, comma C. So here B1 is subset of B3 and B1 is not equals to B3. That's why we have to mark here for this pair as 1. Okay, because B1 is proper subset of B3. Now next pair is B1, B4. Okay. So B1 is consist of C and B4 is consist of set A. So again there is no any relation. No one is subset of another set. That's why we have to mark here 0. Now next one is B1, B5. Okay. Now check for what are the elements of B1. B1 is set C and B5 is set A, comma C. So here we can say that B1 is subset of B5 and B1 is not equals to B5. That's why B1 is proper subset of B5 and we can represent it by marking here as 1. Now next one is B1, B6. Okay. So B1 is set C, B6 is set A, comma B. Again there is no any relation. This is not proper. That is B1 is not proper subset of B6. That's why we have to mark here 0. And next one B1, B7. So B1 is set C and B7 is set A, comma B, comma C. So here we can say that B1 is subset of B7 and B1 is not equals to B7. That's why B1 is proper subset of B7. So we have marked here 1. So likewise we can print for all the places by marking it by either 0 or 1. Are you getting this problem? Many times they have asked this question for 8 marks. So just let me know, have you understood how they have marked here 0 or 1? Or shall I repeat this?
Repeat once again, ma'am.
So again, I will explain you for B0. Okay. Now here first row is B0 and first column is B0. Now we have to mark here either 0 or 1. So how we can decide it? What is the given condition? We have asked this relation is of proper inclusion. So if B0 is proper subset of B0, then only we have to mark here 1. Otherwise, it should be 0. Okay. So now B0 is consist of element 5. Okay. And again B0 is consist of element 5. So what is the definition of proper inclusion? B0 should be subset of B0, but B0 should not be equals to B0. But here, this second condition becomes false. That's why we can say that B0 is not a proper subset of B0. So we have to mark here 0. जर ते दोन सेट सेम असतील तर तिथे 0 येईल, डिफरंट असतील आणि सबसेट असेल तर 1 येईल. ओके. So same condition we have to check for rest of places. Now check for B0, B1. So what is the element of B0? 5 and B1 it is set C. Now we have already seen in set theory 5 is subset of every set. That's why for rest of places we have to mark here as 1 because 5 is subset of every set. And that is not equals to B1, B2, B3, B4, B5, B6 and B7. In short, this is satisfying the condition for proper inclusion. That's why we have to mark here as 1. So, have you understood how we have represented first row B0?
Yes, ma'am.
Okay. Now check for the second row. Second row is B1 and in that first column is B0. Now again we have to decide whether B1 is proper subset of B0. Now what is the element of B1? B1 is equals to set C and B0 is equals to 5. Now check whether set C is proper subset of 5. No. 5 is subset of every set, but set C is not subset of 5. That's why we have to mark here 0. Now second condition, that is second column is again B1. So B1, B1. B1 is equals to set C, again B1 is equals to set C. So this is not satisfying the condition for proper inclusion. That's why we have to mark here 0. जेव्हा दोन्ही सेट इक्वल असतील तेव्हा तुमचं 0 सेट आहे because that is not satisfying the condition for proper inclusion. Now check for the next column, that is B2. So B1, B2. What is the element for B1? It is set C and for B2 it is set D. Now check whether B1 is subset of B2. No, that's why we have to mark here as 0. And B1 is not equal to B2. Means what? It is satisfying the conditions for proper subset. That's why we have to mark B1, B3 as 1. For this pair, we have to mark it one as 1 because B1 is proper subset of B3. Now next one is B1, B4. B1 is equals to set C, B4 is equals to set A. Now again, there is B1 is not subset of B4, that's why we have to mark here as 0. Now next one is B1, B5. B1 is equals to set C and B5 is equals to set A, C. So here we can say that B1 is subset of B5 and B1 is not equals to B5. That's why this is proper subset of B5. So we have to mark here as 1. Now next order pair is B1, B6. Okay. So B1 is consist of set C and B6 is set A, B. So again B1 is not subset of B6 because C is not present here. So we have to mark this one as 0. And next one B1, B7. So B1 is set C and B7 is set A, B, C. So again B1 is subset of B7 and B1 is not equals to B7. So we have to mark this one as 1. Hello? Have we understood how we have solved first two rows?
Yes, ma'am.
Okay. So can anybody
Yes, ma'am.
explain for B2 how we have represented this row as 0 and 1? Yes, just like B0, B1. Again we have to decide for B2 where we have to write 0 and 1. Okay. So here B2 is equals to set B. Okay. And B0 is equals to 5. So again B2 is not subset of 5. So we have to mark here 0. Now next one is B2 B1. So B2 is consist of set B and B1 is consist of set C. So again B2 is not subset of B1. So we have to mark there at 0. For B2, B2, obviously it is 0 because every this two sets B2 and B2 these are equal sets and these are not satisfying the condition for proper subset. So for same set there will be 0. B2, B3, B2 is set B, B3 is set B, comma C. So again, B2 is subset of B3 and B2 is not equals to B3. So this is the satisfying this is satisfying the condition for proper subset. So we have to mark here as 1. Now next one is B2, B4. So B2 is equals to set B, B4 is equals to set A. So B2 is not subset of B4, so we have to mark there as 0. Now next one is B2, B5. B2 is set B, B5 is set A comma B, A comma C. So again B2 is not subset of B5, so we have to mark there as 0. Now next one is B2, B6. So B2 is set B, B6 is set A comma B. So here we can say that set B2, this is subset of B6 and B2 is not equals to B6. So B2 is proper subset of B6. So we have to mark there as 1. Now next one B2, B7. So B2 is set B, B7 is set A comma B comma C. So again B2 is subset of B7 and B2 is not equals to B7. So we have to mark there as 1. So likewise for rest of places again we can identify whether it is 0 or 1. Now check for B3 and B7. We have marked here as 1. Why? Because B3 is consist of set B comma C and B7 is consist of set A comma B comma C. So here again we can say B3 is subset of B7 and B3 is not equals to B7. So B3 is proper subset of B7. That's why only for this pair B3 and B7 we have marked as 1. And for rest of places is set A comma C. So here set B4 is subset of B5 and B4 is not equals to B5. That's why we have marked this one as 1. Now next one is B4 B6. So B4 is set A and B6 is set A comma B. So again this B4 is subset of B6 and B4 and B6 are not equal. That's why we have to mark this one as 1. Then next B4, B7. So B4 is set A, B7 is set A comma B comma C. So again B4 is subset of B7 and these are not equal sets. That's why we have to mark as 1. Now check for B5 row, B5, B7. For this pair we have marked as 1. So B5 is A comma C and B7 is set A comma B comma C. So again B5 is subset of B7 and these two sets are not equal. So we have marked as 1 here. And for B6 and B7 we have marked as 1 because B6 is A comma B and B7 is set A comma B comma C. So again we can say that B6 is subset of B7 and these two sets are not equal. That's why we have to mark there as 1. And for B7 check whether any another set is containing A, B, C or A, B, C, D, all the elements of B7? No. There is no such element or no such a set which is containing A, B, C as a subset. That's why for this row B7, for all the places we have marked as 0. So in this way we can form a matrix for this given relation. Have you understood this example?
Yes, ma'am.
Okay. So next point we have to see is that equivalence relation. So definition for equivalence relation is given here. A relation R on set X is called an equivalence relation if it is reflective, symmetric, and transitive. Means what? If it is satisfying reflective, symmetric, and transitive property, that is RST. If that relation is satisfying these three properties, then only that relation is called as equivalence relation. So this definition is very important. Again, based on this point also, you will get a question for 4 marks in final exam. So first of all, take down definition for equivalence relation. Then we will solve some examples based on it. Okay. So here I have seen a relation which is satisfying reflexive, symmetric, and transitive property is called as equivalence relation. Okay. So here first question is given. Let set x is equals to 1, 2, 3, 4 and relation R is defined as set of order pairs. Then write the matrix of R and sketch its graph. Okay. So here a relation is given, and for that relation we have to draw matrix and graph. So first we will check for matrix. Again, this set is consist of 4 elements. So your matrix will be of 4 by 4. 1, 2, 3, 4. These are the rows. Again, 1, 2, 3, 4. These are the columns. So first order pair is 1, 1. So first row, first column, we have to write there as 1. So what is meaning of this one? That order pair is present in given relation. So next one is 1, 4. So first row, fourth column. So again, we have to mark this one as 1. Next order pair is 4, 1. So fourth row, first column. So we have marked here as 1. Then 4, 4, fourth row, fourth column. So again, we have marked here as 1. Then 2, 2, second row, second column. Mark here as 1. 2, 3, second row, third column. So again, here it is 1. 3, 2, third row, second column. So again, it is 1. And 3, 3, that is third row, third column. So again, we have to mark that one as 1. So this is the matrix for given relation. Now we have to draw a graph for this particular relation. So check here. Order pairs 1, 1, 1, 4, 4, 1. So here we can take two elements of this set, that is 1 and 4 together, because there is a relation between these two elements. First element is 1, second element is 2. So first order pair is 1, 1. So we have to draw self loop, because that order pair is starting from 1 and ends at 1 only. So there is a self loop at 1. Next one is 1, 4. So that R should start at 1, ends at 4. So this is 1, 4. Then 4, 1. That order pair is starting at 4, ends at 1. So this is the direction of arrow. And 4, 4. So again there is self loop at element 4. So this is regarding all these order pairs. Those are related with 1 and 4. Now next order pairs 2, 2, 2, 3, 3, 2 and 3, 2. So again we can draw two circles to represent element 2 and 3. So this is the circle for 2, this is the circle for 3. Now first order pair is 2, 2. So again there is a self loop at element 2. Then 2, 3, that is R is starting at 2, ends at 3. Then 3, 2 starts at 3, ends at 2, and 3, 3. So again there is self loop at 3. So this is the graph for given relation. So in this way we can draw graph and matrix for any relation. So have you understood this question? How we have represented this relation using graph and matrix?
Yes, ma'am.
Okay. Next question. Let X is equals to consist of set of elements 1 to 7 and R is equals to order pair X comma y such that X minus y is divisible by 3. So here they have directly not given any relation. Set X is given and definition for relation R is given. From that relation, we have to find out what is the relation. What would be the order pairs? Those can be included in relation R. So show that R is an equivalence relation. Draw the graph of R. Okay. So here we have to define relation R. So can anybody tell me what would be the order pairs those we can include in relation R? Condition is given. This relation R is defined on set X, which is consists of elements from 1 to 7. and x minus y is divisible by 3. If there is any order pair x comma y, then x minus y is divisible by 3. So this is the condition. So what are the order pairs in relation are
1,4 and 4,1.
1 comma 4, 4 comma 1. Correct? Next
7, 1, 7.
is 7 comma 1, 1 comma 7. Again 4 comma 7, 7 comma 4. Because 7 minus 4, it is 3. 3 is divisible by 3. Again 4 minus 7 minus 3. Again it is divisible by 3. So again remaining order pairs like 2 comma 5, 5 comma 2, 3 comma 6, 6 comma 3. Again all the order pairs 1 comma 1, 2 comma 2, 3 comma 3, 4 comma 4, 5 comma 5, 6 comma 6 and 7 comma 7. So why we have included all these order pairs? Because 1 minus 1 it is 0 and 0 is divisible by 3. 2 comma 2 again 2 minus 2 again it is 0. So likewise for all these order pairs it is giving result as 0 after performing subtraction operation and 0 is divisible by 3. So don't forget to add these order pairs. Now we have defined this relation R. Again, for this relation R, we have to draw a graph. So again, we have to check how many elements are related there. 1, comma 7, 4, comma 7, 7, comma 1, 7, comma 4. So if you observe these four order pairs, we can say that 1, 4 and 7 are closely related. That's why we can take these three elements together. This is circle for 1, circle for 2, circle for 7. Okay. So first order pair is 1, comma 7. So we can draw a R that is starting at 1 and ends at 7. So this is that R. Now next one is 4, comma 7. So starts at 4, ends at 7. Again there is another order pair that is 7, comma 4. That's why again there is reverse order pair that is 7, comma 4. So reverse arc is given here. Likewise 7, comma 1 is there. That's why reverse arc is there. Again there is order pair 4, comma 1 and 1, comma 4. That's why we have represented it by 2 arcs. Again, there is self loop at every element 1, 4, 7. So 1, 1 is represented by this self loop. 4, 4 is represented here by this self loop, and 7, 7 is represented by this self loop. Okay. So this is for all the order pairs. Those are related with elements 1, 4, and 7. Now, next 3, 6, 6, 3. Again 3, 3, 6, 6. So for these four order pairs, we can take two elements 3 and 6. Those are represented by these two circles. So first one is 3, 6. So there should be arc from 3 to 6. Again 6, 3. There should be a reverse arc. Again 3, 3. There is self loop at 3, and for 6, 6. There is self loop at 6. Now rest of order pairs are 2, 5, 5, 2, 2, 2, and 5, 5. So again for these four order pairs, we can take two elements. That is circle for 2, circle for 5. Again, there is order pair 2, 5. So that order pair is represented here by this R, and 5, 2, this is represented by this reverse R. And there is order pair 2, 2, means for self loop at 2, and 5, 5, self loop at 5. So this is the graph for this given relation. Are you getting this problem? This is very simple. Just we have to see what are the order pairs in relation, and from those order pairs we have to draw a graph. Yes, have you understood?
Yes.
Yes, ma'am.
Okay. So here in this question, relation R is given and that is defined by all these order pairs, and we have to check whether this is an equivalence relation or not. Okay. So already we have seen definition for equivalence relation, a relation that is satisfying reflexive, symmetric and transitive property is an equivalence relation. Now look at this relation R and tell me whether this one is an equivalence relation. Check for reflexive, symmetric and transitive property. Whether this one is a reflexive,
Yes, reflexive.
yes. Why?
Ma'am.
Yes.
A comma A,
Hello.
B, C comma C, C comma D, and E comma E present.
Yes. All the order pairs like A comma A, B comma B, C comma C, D comma D, and E comma E. All these are present in this given relation. So this one is a reflexive. Second property, symmetry. Now check whether this one is symmetric. Check for the reverse of every order pair. So this is symmetric because A comma B, B comma A is there, for D comma E comma D is there. So reverse of every order pair is present here. So this is a symmetry. Now check for transitive.
Yes, it is transitive.
How? Just tell me one example how you have checked the transitivity.
Order pair A comma A and A comma B. A get
Okay.
cancelled and
Yeah.
order pair A comma B is present.
Yes. Order pair A comma B is present. Likewise, we have to check for every such order pair. So again, we can take B comma B. So for this B comma B, we can take order pair as B comma A. So this B will get cancelled, you will get B comma A, and that is present in our relation. Like for A comma B, again B comma B, this B will get cancelled, you will get A comma A, and that is also present in this given relation. So if you check for every pair of this, every order pair of this relation, you will get this relation as transitive. So this given relation is satisfying reflexive, symmetric and transitive properties. So this is an equivalence relation. Now again, we have to solve some examples based on relation matrix and graph of relations. So question number 1 is given. Let A is equals to set 1, 2, 3, 4. B is equals to set B1, B2, B3. Consider the relation R, which is consists of all these order pairs. Then determine matrix of relation. So here they have asked to find out matrix of relation. So first of all, tell me what would be the order of that matrix? How many rows will be there and how many columns will be there?
4 rows and 3 columns.
Yes, 4 rows and 3 columns. So rows are 1, 2, 3, 4, and columns are B1, B2, B3. So 1 comma B2. So if you consider this order pair, this one is row, B2 is column. So for this particular row and column, we have to mark there as 1 because this order pair is present in this given relation. So 1 comma B2, we have to mark this one as 1. Next one, 1 comma B3 is what? 1 is row, B3 is column, and again for this order pair, we have to mark here as 1. Next one, 3 comma B2, 3 is row, B2 is column, we have to mark there as 1. 4 comma B1, 4 row and B1 is column. So again, we have to mark here 1. 4 B3, 4 row and B3 is column. Again, we have to mark here as 1. Again, for rest of places, we have to mark 0 to represent those order pairs are not part of given relation. So this is the matrix for relation. Okay. So here in this second question, they have just changed the style of question. Let A is equals to 1, 2, 3, 4 and find the relation R on A determined by matrix. So here they have given you matrix and from that matrix you have to define relation. Okay. So matrix is given and from this matrix you have to identify what is the relation for given set. So do you have any idea how we can define relation from this given matrix? In the previous example, what we have done, relation R is given and from that relation we have drawn matrix here. But in the second example, they have given you matrix and from that matrix you have to identify relation. Again, relation means what? Set of order pairs. It's 1 comma 1. Second
1 comma 3,
is 1 comma 3. Then
2 comma 3,
2 comma 3.
2 comma 3, 3 comma
3
1,
comma 1,
3 comma 1.
4 comma 1, 4
Yes.
comma 2, and 4 comma 4.
Yes, correct. So whenever we have written one there, we have to take that one as other pair of given relation. So one is here, 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 and 4, 4, 1, 2, 3. So all for all these places we have to consider that order pair is present in relation. So 1 comma 1, 1 comma 3. Again for this second row 2 comma 3. Then third row 3 comma 1 and for fourth row 4 comma 1, 4 comma 2 and 4 comma 4. So this is the relation for given matrix. Good. Third question, let A is equals to set 5, 6, 7, 8 and R is given as set of order pairs x, y such that x is greater than y. Then draw the graph of relation R and also give its matrix and properties satisfied by A. So set A is given and relation R is defined on set A. And here they have given one important condition for relation R. We have to include such order pairs where x is greater than y. So first element of your order pair must be greater than second element. So first of all define relation R. Okay. So what would be the order pairs those we can include? Yeah. Yes, what are the order pairs? what happened? Just you have to check for every first element of that order pair must be greater than second element. That's it. I
6
will tell
comma
you.
5, 7 comma
Okay.
5,
Yeah. Huh.
7 comma 5, 8 comma 5,
Okay.
7 comma 6, 8 comma 6, and 8 comma 7.
7. Okay. Correct. So all these order pairs we can include because for this every order pair, first element of that order pair is always greater than second element. Now, for this, we have to draw matrix and we have to draw graph. Also, we have to identify properties satisfied by it. So, first we will go for matrix. So, can anybody tell how we can draw the matrix? That matrix would be of order stationary 3 by 3, 4 by 4.
4.
Hence, that would be of 4 by 4 because they have defined this relation on set A and which is consist of 4 elements. So that matrix will be of 4 by 4, that is 5, 6, 7, 8, 5, 6, 7, 8. Now, first order pair is 8, 5. So, 8 and 5. For this, we have to mark as 1. Then next one is 8, 6. We have to mark here as 1. 8, 7. Again it is 1. 7, 5. 1. 7, 6. 1. And 6, 5. Again for this it is 1. And for rest of places we have to mark as 0. Now we have to draw graph of this relation. So again this relation is consist of a set which is again containing 4 elements as 5, 6, 7, 8. So we have represented this one by 4 circles. Now first order pair is considered 6, 5. So there should be a direct line from 6 to 5. Check for this direction of arrow. This is from 6 to 5. Next one, 7, 5. So starts at 7, ends at 5. 7, 6 starts at 7, ends at 6. And 8, 5, 8 to 5, then 8 to 6, 8 to 6, 8 to 7, here 8 to 7. So I think we have included all the other pairs. So graph of this relation will be look like this. So till so far we have find out graph and matrix of relation R. Now we have to identify what are the properties satisfied by this relation R. Now check for the properties of this given relation. Whether it is reflexive, whether this relation is reflexive,
Irreflexive, ma'am.
is irreflexive because there is no such a reflexive factor. Now check for whether it is symmetric.
Antisymmetric, ma'am.
Is antisymmetric. And now check for whether it is transitive.
Yes, ma'am. Transitive property is there.
Yes, that's right. This given relation is irreflexive, antisymmetric, and transitive. These three properties are satisfied by relation R. Okay. Next question. find the relation determined by graph and corresponding relation matrices. Also determine properties of relation given by graph. So here graph is given, and from this graph we have to determine first what is the relation, then what are the properties satisfied by given relation, and what is the matrix for given relation. So first we will find what is the relation defined by this graph. So can anybody help me how we can define the relation? What are the order pairs we can include?
A1,
A4 comma A1, A1 comma A4, A1 comma A2,
Okay,
A2 comma A1, A2 comma A3,
okay,
A3 comma
yeah,
A2. नंतर A
okay.
comma
And for this
A4, A4 comma A4, A1 comma A1, A2 comma A2, and A3 comma A3.
is correct. All these order pairs we can include in relation from this graph. Now next point, we have to represent A with the help of matrix. So this matrix will be of order 4 by 4 because there are 4 elements A1, A2, A3, A4. So again A1, A2, A3, A4. So for this order pair A1, A1, we have to represent this one as 1. A1, A2, this order pair is also present, so we have to mark as 1. A1, A4, this is also present. Now for A2, A1 is there, A2, A2 is there, A2, A3 is there, so we have to mark as 1. For A3, A2 is there, A3, A3 is there, and for A4, A1 and A4, A4 is there. So we have to mark as 1. And for the rest of places, we have to mark as 0 because those are the pairs are not present in given relation R. Now next question is, what are the properties satisfied by relation? Now tell me, what are the properties satisfied by this given relation?
it is reflexive.
Yes, it is reflexive. Correct. Next one. Check for symmetry.
Yes, symmetric.
Yes, correct. Now next one is check for transitive.
Yes, transitive.
Yes. So any another property? I think only these three properties are satisfied by this given relation. Reflexive, symmetric, and transitive. Check for transitive whether it is transitive. A1, 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 A2. Final answer is A1, A2. Next one A2, A2, A1, A1. Okay, correct. Yes. So reflexive, symmetric, and transitive. These three properties are satisfied by this given relation. So we can say that this relation is equivalence relation because it is satisfying reflexive, symmetric, and transitive properties. Next question. Question number 5. If relation R is given by this set of order pairs, then draw the graph to represent relation R. Okay. So first we will draw a matrix for this given relation. Again, that matrix will be of 4 by 4, 1, 2, 3, 4, 1, 2, 3, 4. So first order pair is 1, 1. So 1, 1, we have to write here 1, 1, 3, 1, 2, 3, we have to write as 3, sorry, 1, 3, 2, 1, 3, 3, Here is 1, 4 comma 3. Again, here it is 1. So here we have find out what is the matrix. Now we have to draw graph for this given relation. So here 4 elements are present. 1, 2, 3, 4. So first order pair is 1 comma 1. Means what? We have to draw self loop at 1, and that is shown here. Then 1 comma 3. 1 to 3. There should be a R. Yes, that is given. 2 comma 3. 2 to 3. Yes, that is also given. 3 comma 2 starts at 3, ends at 2. Then 3 comma 3 is self loop at 3, and 4 comma 3 starts at 4, ends at 3. Yes, so this is the graph for given relation. Now, next few questions are based on equivalence relation. Okay, here set X is given, which is consist of 4 elements, 1, 2, 3, 4. Relation R is given, which is consist of set of order pairs. Then prove that R is an equivalence relation. So this kind of questions they have asked for 4 marks. So again, your matrix will be of 4 by 4, 1, 2, 3, 4, 1, 2, 3, 4. First order pair is 1 comma 1, that is they have marked here 1, then 1 comma 4, 1, 4 comma 1, they have marked as 1, 4 comma 4, they have marked as 1, 2 comma 2, this 1, 2 comma 3, this 1, 3 comma 2, 1, and 3 comma 3, again it is 1. So this is the matrix. Now we have to draw what is the graph for this relation. Again, if you check, there is close relation between 1, 4 and second one 2, 3. So first of all, we have to represent all of these first four order pairs by this first graph, and that is consist of 1 and 4. So these two elements are represented here by circles. Then first order pair is 1 comma 1. Means what? There is self loop at 1. The next one is 1 comma 4. So there should be a R from 1 to 4. Next one is 4 comma 1. So there should be a reverse arc from 4 to 1. And last order pair is 4 comma 4. So again there should be a self loop at 4. So this is for all the order pairs. Those are related to 1 or 4. Now next one 2 comma 2, 2 comma 3, 3 comma 2 and 3 comma 3. So again these four order pairs are related to element 2 or 3. So here they have taken 2 elements. First element is 2, second one is 3. So 2 comma 2 is represented here as self loop at 2. Then 3 comma 3 is represented by self loop at 3. Then 2 comma 3, this is R, and again 3 comma 2. This is the reverse R. So this is the graph for relation R. Now we have to check whether relation R is an equivalence relation. Now check whether it is satisfying reflexive, symmetric and transitive properties. Whether it is reflexive,
Yes, reflective.
symmetric,
Yes.
symmetric, and for transitive,
Yes, transitive.
transitive also. So it is satisfying reflexive, symmetric and transitive properties. So we can say that this relation R is an equivalence relation. Question number 2. Let A is equals to set ABC, B is equals to set 1 comma 2. Then relation R is consist of set of order pairs. Is a relation from A to B. Then find inverse of relation R, that is R inverse. Okay. So relation R is given and we have to find inverse for this given relation. So how we can find the inverse? Just we have to change or interchange the position of elements from each and every order pair. Then it will give you inverse of given relation. So relation R is given, from that we have to find R inverse. So here first order pair is A comma 1. So this is order pair for relation R. So in order to find out its inverse, we can interchange the position of these elements. So first order pair will be 1 comma A in R inverse. आपल्याला काय करायचं फर्स्ट फक्त त्यांची पोझिशन इंटरचेंज करायची प्रत्येक ऑर्डर पेअर मध्ये. Now second order pair is A comma 2. So in R inverse we can include order pair 2 comma A. And for this third one, C comma A, C comma 1, we can write 1 comma C. So this is the R inverse for given relation. So you have to just interchange the position of elements in each and every order pair. So that will give you R inverse. So second question is given. Let A is equals to ABC and relation R is given by set of these order pairs. Then find R inverse. So now tell me, what are the order pairs we can include in R inverse? Yes, you have to interchange the position of elements in every order pair.
A comma A, B comma A, C comma A, and C comma B.
Yes, correct. So this is the answer for R inverse. Good. Third question. Let X is equals to set of elements from 1 to 7 and R is equals to set of order pairs X comma Y such that X minus Y is divisible by 3. Then show that I think we have covered this question. Yes. In the previous set of questions, we have covered this. Let's see next one. Determine whether a relation R is an equivalence relation. So for this question number 4, they have given set of order pairs, and from this we have to determine whether this one is an equivalence relation. So first of all, tell me what are the properties required to satisfy by any relation to become an equivalence relation.
Reflexive, transitive, and symmetric.
Reflexive, transitive, and symmetric. Now check whether this one is reflexive.
No.
No. So this is not an equivalence relation. For the equivalence relation, it should satisfy all three properties: reflexive, symmetric, and transitive. But this given relation is not reflexive. That's why we are not going to check for rest of properties. Directly we can say that this is not an equivalence relation. Okay. So this sixth question is based on equivalence class. I think that is not still not yet covered. So temporarily we are going to skip this question. So today we are going to stop here. Next lecture we will see what is the converse of relation, how to find composition of relation, and all that part, that is partial order set and all that. So today we are going to stop here. So before that, give me presenting. Roll number 1.
Yes, ma'am.
2, roll number 2, 3,
Yes, ma'am.
4, roll
Yes,
number
ma'am.
4, 5,
Present, ma'am.
6,
Present, ma'am.
7, 8,
Present, ma'am.
9,
Present, ma'am.
10, 11,
Present, ma'am.
12, roll number 12, 13,
Yes, ma'am.
14,
Present, ma'am.
15,
Present.
16,
Present, ma'am.
17,
Present, ma'am.
18, 19,
Present, ma'am.
20,
Present, ma'am.
21,
Ma'am.
22, 22, 23,
Present, ma'am.
24,
Present, ma'am.
25,
Yes, ma'am.
26,
Yes, madam.
27,
Present, ma'am.
28, 29,
Yes, ma'am.
30,
Present, ma'am.
31,
Present, ma'am.
32,
Present, ma'am.
33,
Present, ma'am.
34,
Present, ma'am.
35,
Present, ma'am.
36, 36, 37,
Present.
38,
Present.
39,
Yes, ma'am.
40,
Present, ma'am.
41, 42, 43, 44, 45,
Yes, ma'am.
46, 47, 48,
Yes, ma'am.
49,
मॅडम 49 आहे लेक्चर मध्ये त्याला रेंज प्रॉब्लेम आहे.
50, 51,
Yes,
Present,
ma'am.
ma'am.
50 is present, 51 is present,
Yes, ma'am.
52,
मॅडम
52, 53, 50,
हॅलो मॅम, त्याचा माईक बंद
थोड़ा
आहे.
सा,
ते 53 चा त्यांनी चॅट बॉक्स मध्ये टाकली.
54,
Yes, ma'am.
55,
Yes, ma'am.
56,
Yes, ma'am.
57,
Yes, ma'am.
58, 59,
Yes, ma'am.
50, 60,
Yes, ma'am.
present. 61,
Present, ma'am.
62,
Present, ma'am.
63,
Present, ma'am.
64, 65,
Present, ma'am.
66,
Present, ma'am.
67,
Yes, ma'am.
68, 69, 70.
Present, ma'am.
Okay, so check for, yeah, hello?
0 to present, ma'am.
Okay.
2.
Ma'am, roll
Yeah.
number 7 present.
Roll number 7.
Ma'am, 42 present.
52. 42.
42.
Okay. Hmm. Roll
12.
12. Okay. Now take for today's numbers 22, 28, 36, 41, 43, 44, 46, 47, 52, 58, 64, and 68.
Hello, ma'am.
Huh?
Hello. 58 is present, ma'am.
Hello?
58
Okay,
present, ma'am.
58 is present. Okay. Okay, so today we are going to stop here. Thank you.